Well, thank you for hanging out for the last session of the day. Quick tease though, when you do a session, you get to tease your other sessions. Please do come tomorrow at 11 o'clock for the final keynote. Myself and Anna Hoffman, we'll be talking about SQL and AI across everything. One of them will be hyperscale. So some of the things you're going to see today will be also shown in the keynote, but I'll reserve a few things tomorrow that I don't want to talk about today. I'm Bob Ward from Microsoft. I'm a principal architect. I was talking to some folks here earlier. I'm actually based out of Texas. So this is a great time of the year for me to be here. It's 102 now, it's already 102 now at my house and 78 outside here, right? So, plus it's also an opportunity for me to come to what I call the mothership, mothership being the campus of Microsoft. So me not being just here presenting, the rest of the time I'm across the highway, building what we call Building 44. Building 44 and 43 are the headquarters of Azure Data Engineering, which is a group I work for. One of the products that we focus on is SQL. You see SQL's everywhere that you know about, and one of them is a product called Hyperscale. Hyperscale, if we could change the clock back in 2016 when that project started, we would not have called it Hyperscale. We called it Hyperscale because at that time, we were trying to convince the world that in the cloud for Azure SQL, we could scale to the largest databases in the world because nobody thought we could. And there was limitations behind how the SQL Server architecture ran that caused that. Nowadays, people think it's only for the largest databases. So I hope one of the things I'm going to dispel today is that myth. It's not just for the largest databases. It can be. But think in terms of starting with hyperscale now in the cloud and moving to the largest databases you need. A couple logistics. It's a pretty small audience. Let's make it interactive, right? I can walk around and take your questions. I definitely want to make sure I answer your questions. But here's some resources for you. The deck is already here at this location, Bob Ward MS. I will put up the final slide that has these links again, so if you forget to take a picture of it. But if you just want the deck, if you want to take the deck and present it to yourself or present it yourself to somebody else and make money off it, I don't care. I just want you to learn hyperscale, right? I have a set of demos today using a GitHub repo. The files for that repo for all the scripts, all the code, the databases, everything is right here, Bob SQL Demos. There's a folder called Hyperscale Developer. And in there is everything you need, and I'll show you a segment that looks like. In addition, my colleague Anna Hoffman and I that are going to do the keynote tomorrow, we recently just wrapped up filming a series that'll be on YouTube called Azure SQL Foundations, in which we'll go over hyperscale in a series of videos for you to watch. And so this site is not up yet, but it will be in a couple of weeks because I got to finish it. It's another GitHub repo that shows you a hyperscale end-to-end scenario of building it, migrating it, using it from an application point of view. So we have plenty of resources for you to go back and look at. And in fact, one of the things I love about the demo that I built is I built a series of run books and skills for you to use in Visual Studio Code. So you're going to see me when I got these demos, go into GitHub Copilot and say, let's run demo 1, and it'll tell me what to go do so I don't forget. But you can do the same thing. So if you see these demos and you're worried about, I don't know how to go through these things like Bob did, you have everything you need to go do that. Okay, let's go ahead and start with something fun though. So to dispel this myth about hyperscale, you got to start with a trivia. Survey says, kind of like, the show, right? So let me ask you guys this question. What is the minimum number of vCores for a hyperscale database? Anybody know? 2 is the right answer. But did you know, when I've done this session before, and I've done a bunch of them, right? I've heard 16, 32, 64, a bunch like that. I'm like, no, it's just 2. 2 vCores is the minimum, which tells you can start small, right? What was the project name for hyperscale? I love doing history at Microsoft because I've been around a long time and I'm old. Anybody know what the project name was? So you didn't read the book by Bob Ward called Azure SQL Revealed, in which in that book said the name of the project. It was called Socrates. Because one of the junior developers, who's now an architect for us, one of the developers was always asking questions in the project, and these superstars of the SQL engineering team. And so they let him name the project, and of course he picked the name Socrates because he's asking questions all the time. Can hyperscale support serverless? True or false? True, it can. It doesn't support auto pause yet, but that's coming. That is absolutely on our roadmap. So soon it will support auto pause as well. What about PITR, point-in-time restore? Does anybody know in general how fast we can do a point-in-time restore in hyperscale? Any thoughts? Look at it, I love that word, fast. How about this for you? 40 terabytes in 7 minutes. We can restore a 40 terabyte database in 7 minutes. And I'll explain in the architecture why we can pull that off. What is the min and max size of a hyperscale database? Like when you start one, what is the smallest size you get? You say 0? Okay. Anybody else want to take a shot? 10 gigabytes. So here's one thing about hyperscale. You don't tell us how much storage you need. We just build a database of 10 gig. And then you start growing it. And you can grow up to what number? Anybody know? 128 terabytes. So you can go from 10 gig to 120 megabytes. And you're going to find out you can go from 2 vCores to 192. Which is why we say, we believe you can start small and scale to your needs. Let's try to prove that today a little bit. Let's do it in this fashion. Now, whenever I build these presentations, I have to admit to you, I try to pour so much stuff in these things, right? Because I don't want to lose, saying something to you. So it's possible in some of these areas we may not go over every detail, but in general, as I was thinking about the idea of a developer guide, and especially if you know SQL Server, I kind of assume you might know SQL Server. So let's talk about the fundamentals of hyperscale. Let's talk about how you go build one of these things. Let's talk about how you secure it different than you might SQL Server, scale it, make it highly available, and modernize it. That's going to be the outline of the developer's guide. Then again, keep in mind, start small and scale to your needs. All right, is this SQL Server? Let's prove it. It is the same engine as SQL Server itself. The same code base for hyperscale is the code base of SQL Server. So it's the same T-SQL language. Are there some features that don't exist in hyperscale in SQL Server? Yes, but there's reasons for the platform, not because of the engine. For example, you can't do cross-database queries today in hyperscale. It's an isolated contained database in a tenant where we can't allow that to occur, at least today. We're working on that one, actually. So there are some things like that that don't exist, or instance level things from SQL Server, but at a database level, same thing. The SQL OS powering SQL Server and the query processor are unchanged, which means for you, it's very nice because for the most part, your apps don't break. They're very compatible to move from SQL Server to hyperscale. Same backup restore code as using in SQL Server, although we automate it, but it's radically different. It's that point-in-time restore that I'll talk about. That's the different part. Your existing apps can migrate without code changes. Change a connection string and you're ready to go. And the hyper part is not the engine, but the architecture. And we'll show you the architecture a little bit to show you why we build a distributed platform of SQL servers to achieve that dream I told you when we first started the project. We wanted to go scale the largest databases in the world. It's hard to do that on a single instance of a virtual machine. So we built a distributed architecture to make that possible. Okay, so what is hyper about this? It is distributed, but here's the part that's interesting. Your compute and your storage are separate. And I'll show you in a diagram what I mean by that. Zone redundancy is built into the architecture with high availability built into the architecture and a really cool thing called named replicas, which I'll talk about in the architectures. What is that named replica? Here's how we achieve that point-in-time restore. We use snapshots. A snapshot backup is used. And because of our architecture, we're allowed to do this. We can do a snapshot backup. And then when we got to do a point-in-time restore, we can easily apply a snapshot, which is an incremental, version of this database, and then apply the log changes. This is why it can happen so fast. Okay. This is kind of, yeah, go ahead. You had a question. Yeah, go for it. I'll repeat her question.
Why is not without the hyperscale, but the business critical or the general purpose, we ought to use external data source and external data table based on that source? You say it's hyperscale.
So the question is in Azure SQL database and these other service tiers, we can do external tables, external data source, and yes, hyperscale does support that. Same as you do in Azure SQL database in general purpose, yes.
Okay. And the second question.
But by the way, that's not a true cross-database query like a 4-part name you could do in SQL Server. But yes, you can technically go across another database with what you're talking about.
Yeah, we build a view on entire.
Right. But the query processor is not as efficient as in SQL Server where you can just have like 4 databases and just join each other. It's not as efficient, but it still does actually work. Yeah.
Answers my question.
Okay.
The one is about the snapshot.
Yes.
Is it like real-time replica? So if the main database people enter things and then it will instantly become available.
the question is that how do we do replication of data? Is that kind of the question? I'll answer it right here in this diagram. Look at this face. You know, when you're an architect at Microsoft, you are required to show an architecture diagram. Like if you have that title, you better show one or else you're not an architect, right? So without making this too complicated, let me break it down for you why it's just distributed architecture. You see where it says primary compute up there and SSD cache, read write? That's like your normal SQL Server, okay? It's got a buffer pool. It's where your read write endpoint is. That's where you write all your changes to. But that's cool, Bob, but how are you going to support a 128 terabyte database in a single compute? Like, you don't have enough RAM for that, right? Well, this is where it gets interesting. So number one, we have an additional cache from the buffer pool, which is an SSD disk cache. And the engine, the SQL Server engine that runs on Hyperscale, that's one part that's a little different. It understands how to go read from that cache if it's not in the main buffer pool. So already we can extend our memory on a primary compute just by having that cache. Do you see down below it this idea called page servers? Those are SQL servers. They're covering, in other words, they cover the rest of the database. So if we can't find pages in those caches, we go to these other SQL servers and say, get the page from there. But those have buffer pools. So you see now the distributed architecture, we can quickly go get pages for large data sets without having to rely on the memory to be large on the primary compute. You don't know this is happening. SQL Server handles all this for you, but we're using a distributed set of SQL servers to make this possible. And at the bottom layer here is Azure storage for the actual data files. Once a SQL server is up and running with a database, it's very rare we have to even go to the data files themselves. The only time we really use those is if we have like to set up another compute somewhere where we can't access these and set up these page servers again. If we have to do that, we have to go access files or these backups. Because we rarely have to touch these, we can do these file snapshots at this level. That allows us to make this point-in-time restore so quickly. Well, it's interesting, Bob. What is this log service thing? So it turns out we had actually instrumented SQL Server to support a remote transaction log separate from the compute itself way back before Hyperscale was invented. We already had this concept. So we have a separate compute going on where the transaction log is hosted. An actual piece of software is running there that takes in transaction log changes, caches them, and writes them to a log. And then these page servers can pull changes from the log to keep themselves up to date. Well, you ask about replicas. So by default, you have 0 replicas, which is kind of like a cluster, right? Like a failover cluster. So if a failover occurs, we spin up another primary compute, point them to these page servers, and we're ready to go. However, you have the ability to add HA replicas, which don't use availability group technology. It's a pull from the log service. So if you say, I want a replica, I'd like a single replica out there, we can point them to the page servers. Now, they will pull changes from the log service to keep themselves up to date. And if you want, you can have up to 4 of these. Why would you have 4 of those? Well, you get more resiliency if you have 4. What if one of them was down? Then a second one could be used at that point to do the failover. And these changes are all up to date. So if you go in and you start reading from these replicas, which you can do, you have up-to-date changes you're actually reading from. So it is similar to like an availability group technology, but it's using different processes behind the scenes to actually make the changes happen. You can see now how we can support very large data sets using this distributed architecture. You are shielded from all of this. The only thing that you know is the fact that you've got this primary replica, or use a read intent connection string to connect to the HA replica. And of course, the HA replica can be there for failover purposes as well. It's a very faster failover. But note here, you don't have to have a replica to do failover. It's not required. It's just going to be faster. Also, if you want our highest SLA, which is 4.5 nines, you need an actual HA replica because this zone redundancy concept requires a replica to be there. I'll answer your question in just a second. So we looked at this architecture, we thought it was pretty cool. And then customers said to us, hey, that HA replica, it must be the same compute configuration as the primary because you have to fail over to it, right? So if you've got 32 cores in your primary, an HA replica is doubling your cost, even if you're not using it. Somebody said like, well, I want to do read scale, but I don't need 32 cores to read scale. And this is not like an availability group where I have to have it as a replica. I just want to read from it. So we create this concept called named replicas. These are replicas for only reading, not for HA at all. And they can have a different compute configuration than the primary. they also can pull from these log servers to get their changes. So now you can push your read workloads, and you don't have to even say intent read only. You just say, I want to go to a database, which is a different name over here, and a server, and we will direct you over there and let your read workload run there. You can have 30 of those things. And we're working on dynamic routing across these as well if you set multiple of these things up. That is one of the coolest features of Hyperscale, in my opinion, that other tiers don't have, is I can do read scale at different compute levels, different than what's on the primary compute. I think it's really cool here because of the fact we have these page server technologies that host these pages. We can spin up a replica very quickly. In fact, we can actually spin up a replica without copying any data at all. We just spin the replica up, we point them in these page servers, and anytime somebody reads from it, we just pull the page from the page server, put it in our cache, and we're ready to go. And then as pages are needed, we just keep filling up our cache further. So adding replicas is a super fast operation in Hyperscale because of the fact that this page server technology exists. Now, I've had somebody one time say like, well, that's all really cool. Why do I even care about that stuff? We're just trying to show you the power of our distributed architecture and how we can achieve some of these large-scale databases without requiring you to provision some massive amount of RAM on the primary compute. The other reason we show this architecture is because you need to know what a named replica is and how you would use it. And some of the diagnostics that Hyperscale provides are specific to the architecture. Like, did I get a page from a page server, or what is the current latencies from page server? So sometimes you might see diagnostics where the architecture shows it seems a little bit. So plus, again, as an architect, you must show a diagram, show how impressive this technology is. So, but this is the beauty of Hyperscale, and no other SQL architecture exists like it. Okay, here's some numbers. We kind of went over some of this a little bit. The one thing I wanted to point out over here is this one, that we have a documented transaction log throughput. We're the only cloud provider database to do that, to actually publish, here's our transaction log throughput. And this is getting faster and bigger. You can expect this to go up and up and up and up. So if you're worried about the fact that I can't do ETL jobs or high-powered log type operations for our transaction logging, we can handle it. Our log throughput that we promise can actually do that on the system. Okay, I never talk about costs when I do presentations. I generally don't like talking about pricing and costs. I know that's the reality for you. The reason I put this together is because people have a perception that Hyperscale is super expensive. Let me explain to you why that may not be the case. You only pay for the storage you use, and the fee to pay for Hyperscale doesn't include a license. You simply pay for the compute you use and the storage you use separately. They're not even coupled together. In fact, your storage is not dictated by your compute. So you can have 2 cores and you can have 128 terabyte database. I'm not sure you probably want to do that, but you could technically if you wanted to, right? So that's really nice, the fact that you're paying separately for those different resources, and there's no license fee at all. And then if you use something called reserve capacity or savings plan, you can get up to 55% savings on top of that. Remember we talked about the replicas? Replicas do double your cost, but you don't even have to have one if you don't need one at all. So you may not have to pay for one of those things. And then the replicas, named replicas, independently sized. I did a study of general purpose, one of our service tiers. And I think zone redundancy is a good option for you. I think you should be zone redundant, be highly available. A zone redundant Hyperscale requires a replica, so now you've doubled your cost. But if you go look at zone redundancy for general purpose, it's almost the same because we charge extra to make a GP zone redundant. So if you're going to build a Hyperscale database that's zone redundant, you're effectively going to pay the same cost as a general purpose database. And we feel, also based on this capabilities, we're very price competitive with technologies like Aurora. So if you're thinking, okay, well, Aurora is Postgres, so it's cheaper because it's free. We don't have a license fee either here for SQL Server for Hyperscale. It's the only SQL service to not require a license fee. Compute and storage, that's what you're paying for. A couple of things about things like tools. These tools are not specific to Hyperscale, but these tools are going to show up in these demonstrations, like using the portal or different CLIs for Azure or Visual Studio Code or the MS SQL extension. SSMS works great with it. If you're like, I don't think SSMS works with Hyperscale, it does. It connects to it and looks just like a SQL server to you, except it looks more like at a database level. GitHub Copilot, very well integrated with VS Code and SSMS. And all the other tools you're used to all work really well. There's one tool on this slide that you've never heard of before, because it's the first time I've talked about it publicly, called SQL Sim. This is a new set of simulation tools that I'll be publishing in a public repo here in August, later in the end of August. We'll show you an example during the scale scenario, but if you're looking for a general purpose tool to help you simulate scale for your workloads, this is coming, and I'll show you an example of that today. It's not specific to hyperscale. I just thought it'd be interesting to know that when I'm testing hyperscale for scalability, I use this tool constantly. I guess I'm pretty biased since I built the thing, but it's pretty cool. Have you ever heard and seen me use a tool called OStress before, publicly? This is a replacement for that coming for you to be able to use. Okay, to build hyperscale, what do? Well, you deploy it. You use the Azure portal or a CLI or PowerShell. We even support things like Bicep and Terraform if you're used to those technologies. And if you're thinking about migration, although we don't support native restores of databases from SQL Server, we have a nice service here called the Azure Database Migration Service. So you put that up, you get it going, and in fact, in the Azure SQL Foundation series that's coming up on that you're going to see on YouTube, I will show you how to use a GitHub Copilot skill to prompt you through a migration of hyperscale using DMS. The one thing I thought you should know about hyperscale that's really important is like, what choices do I make at deploy time I can't go back from? Like I can't change. And these are the three. Number one, zone redundancy. You can't decide to do it later. You have to make that choice at deployment time, and it requires a replica. So if you're saying, look, I need to make this decision before I deploy here about zone redundancy, do it before you create it. Because if you make it later, you're going to have to copy your database to another hyperscale to make that happen. The second is backup redundancy. So when you choose a backup redundancy, which can be local, zone, globally zoned, that choice must also be made at deployment time and can't be made later. And database collation. Collation, that's the same decision for general purpose and business critical. That's no different. But I want to make sure you know that you're making these choices. These three things can't be changed. You were asking me earlier a question about general purpose and business critical, about migration between those. Another important thing you know is that you can migrate from general purpose to hyperscale by just changing the service tier and say, I want to go to hyperscale. It's a one-way move for 45 after 45 days. So if you make that move from general purpose to hyperscale, after 45 days, you cannot move back without a database copy operation. Business critical, you can move to hyperscale, but you cannot move back after that point. So keep those in mind if you're moving between tiers within Azure SQL. Okay, can you get more complicated in this diagram? So here's what I did. I went into GitHub Copilot and liberally used my own name with actually also the name of my mom's maiden name, and I built a hospital system, like a digital chart system. I'm telling you right now that I can take GitHub Copilot with Hyperscale and build something like this. Let's look a little bit about it. So the app is a Blazor app. It's going to run an Azure App Service. I'm going to show you running it locally instead of running it in Azure App Service, but you can run this easily in Azure App Service, right? It's got a data access layer. It's also got an actual agent built into it, which we'll look at a little bit later. I want you to notice up here at the top, green, yellow, purple, red. So we're going to cover what are the secure features of hyperscale, what are the scaling features of hyperscale, how to make it HA, and how to modernize it in each category. But the overall architecture looks something like this. You have your app. This app is going to host a couple things. It's first going to host like a digital chart, like a list of patient charts that a doctor might look at. They click in and they can go look at details of the chart. They can do this at like a station. They have to be in the room to do it, right? A digital chart. So the database can host all of this, real time of what's going on in the system. The thing it's going to do is provide for research. So way over here, students can use named replicas to do research of clinical cases. And they're going to be able to use things like vector searching to make that possible. And then the third part of the app is going to be like a chat system, like a clinical assistant system. And this agent over here is going to power that part of it, but all surfaced into a GUI application. In the middle, Hyperscale has primary compute. In this particular case, I think I start with like 8 cores, but I can go from 2 to 192. I will use an HA replica because I do want 4.5 nines zone redundancy. And then, of course, I have the scale of storage. I'm just going to go create a database and just let the hospital data grow as I need. If the data starts to be too large, we have shrink capabilities. So if for some reason you want to move off some of your data somewhere else, you can do that, and then you can go shrink the current storage because you're paying for that. And then from a modernization point of view, in our chart, we're going to use the new JSON type to do certain things to display the chart. If you didn't know this, we have regular expression support in the T-SQL language now. We're going to use that to look at things in the chart itself. And from a security point of view, this is really interesting. We're going to use the concept of a managed identity. Maybe you've heard of that concept. Passwordless authentication. The app itself is going to have a login, but with no password, called a managed identity. You provision this identity as like a token inside Azure. You get a token here for the service, and then you say that managed identity has permission to access this database, and that permission can be at whatever you want to set it at. But then you're thinking to yourself, okay, if doctors are kind of signing into this system, what about their permissions? We're going to do something really clever. We're going to use row-level security to give only doctors permissions for the patients they're seeing. Now, in a real hospital, my son's fiance is a doctor, by the way. I showed her this. She goes, actually, we do share patients, Bob. And I'm like, okay, I'll figure that out complexity later. But for purpose of row-level security, each doctor can only see their own patients. Well, how do I enforce that if we're using a managed identity? This is really cool. We're going to use row-level security in the database. We use this concept called session context. So the app is going to look at the doctor, log with the managed identity, but set the context as the doctor. So SQL, in our SQL code, we can get that context and apply row-level security to the only patients they need to see. This is true security, right? No passwords are required to go connect into this database at all. Now, to support that agent concept, we're going to use this concept, and if you were in my session yesterday, called Data API Builder with an MCP server to expose to the agent only things it needs to see in the database to create this chat experience. And we're going to go further. Inside the patient chart, we're going to allow a doctor in the chart to get assistance, not recommendations, because that's a bad thing to say, right, in the medical world. Assistance. Like, tell me what you think. So what's going to happen is, in SQL, we're going to use a stored procedure to collect data about the patient chart, send it to an AI model in Foundry, and get back results that we can display actually to the doctor itself. That's kind of crazy. Look at that diagram, that architecture. It is possible for you to build an architecture with Hyperscale like this. Let's get some of the pieces. Let me show you a couple things here first. I'm just going to show you the app briefly, and then I want to show you something really cool about the MS SQL extension. Okay, so here is, I want to make sure you know my hub of what I'm doing here. This is all in Visual Studio Code, and one of the things I told you about these skills is I say here like, hey, I want to go run the demo. And it comes and says, fine, Bob, for the demo, go do this. Again, you can go do this yourself if you get this repo. You can go deploy a database and go to these skill sets. So let's go see what the app looks like. One thing I did, because I'm running things locally on my laptop versus running things in Azure, is that this is pre-populated with some things. In other words, I've run some of the search things ahead of time so that if I ran it and we sit here for a minute looking at it, because I'm on my laptop to Azure, we don't want to wait for it. But this is an example of this clinical chart system, right? We call it a unit board. So notice at the top it says all providers admin. I can go at the top here and I can actually change, if I want to, which doctor is using this. I can say, oh, it's one of these doctors here. That'll change the look of the chart. I can actually drill into a patient. This is what an actual patient looks like to go inside it right here. And you can see the different parts of what's going on with the patient. Notes, all sorts of things about vitals and so forth. And you'll see in a second, when we go to modernize, how do you go get assistance? I'm going to run that now because when I come back, I want to go see what the results of that look like. For students, they'll go to research here, be able to put in actual, natural language searches like this. I can say like, hey, elderly with constant congestion. This is going to do a vector search on our named replica to come back with the results. And when that finishes, a student could go through what are similar cases with those types of things, even though constant congestion may not be in the words of the note, because we can use vector searching to pull that off. The other thing we're going to support is this nice little chat system here. So for example, and we're going to run this ahead of time, we can change to Claudia Ward, the future name of my son's fiance. I got permission to use that. This is her patients. We can go over to the chat window and say, hey, show me like, which patient should I prioritize? And this is going to go off and use that clinical assistance system, not based on just the patient chart, but use that agent I talked about to go use Data API Builder to say, look, take all the patients out there, look at all of them, and tell me what you think I should prioritize. Now, how do you think an agent knows how to prioritize patients? It looks at all the symptoms and the notes and everything else, and it has knowledge about medicine. Imagine if, for example, the hospital is using a specific AI model that's trained on medicine. I'm not using that here, I'm using just GPT. it could be really powerful to come back and say, you know what, based on all this stuff, I think you should go look at these patients first. So it's using the combination of AI technology in the app itself with an MCP server to get some model, but pulling data back from these charts. Whereas the assistance in the chart is using a store procedure in SQL itself. So I let these run because I don't want to sit there for minutes. We're gonna come back and look at these when they're finished in a second. Now here is the GitHub repo that I wanted to show you. So when you go to Hyperscale Developer, you have everything you need. You have scripts to build it, to see the demos, to see the source code, the SQL code, the database builder. So don't worry about looking at the details here because you yourself can go in and look at this later and even build it yourself later because their build scripts are all there to make that happen. Even do it on your laptop. And then over here is what the Hyperscale looks like. It's an 8 vCore database. Remember I said though you need to make some choices up front. So one of the things that I've made in this particular case is I said, hey, it's 8 vCores, but it has a replica and zone redundant. Notice that's grayed out. So I can't go back and make changes to that. So I want to make sure I pointed that out to you that I've already deployed this. By the way, I didn't use the portal to deploy it. In fact, I didn't even use code to deploy it. I used GitHub Copilot to deploy it. I said, go build me a skill and a PowerShell script to deploy. I described the Hyperscale database for a hospital system, and it actually built this right for me. I think it took me 3 times to get it exactly right, but it's pretty good to deploy this thing. And it used those toolboxes behind the scenes to all make that possible. So that's the database powering this. I also promised I'd show you just real quick here the name replica. If you go over here in Hyperscale to replicas, here is the named one. This is the part that's really cool. It's using serverless. So I said, hey, for my read scale, for the students, I love my students, but I don't need super, if it takes a couple extra seconds to get the results back, that's okay. I want to pay less for this. So I made the name replica, which I'm just using for student research, to be a serverless to save costs. So it's not using 8 cores all the time. It's going to use just any core it actually needs. And the minimum in this case I use is 1 to 8 cores. So that's as simple as it is to get the platform running. Now, if you want to see what my schema looks like, I thought you might find this interesting. Here is the MS SQL extension connected to this database. Check this out. I'm going to go into Visualize and Design Schema. Now, for me, I don't know about you, but there's a lot of tables here. So I don't know if the visualization's all that impressive, but what I like to see is over here, if I can get this working, is this little Copilot button. You know what it's going to do for me? It's going to allow me to chat with my schema. It's going to go, first of all, do an overview of my schema for me and show me what it thinks it sees in my database, which is really cool. So it's going to go through, I'm going to give you an overview of what I see. And then you can start asking questions about this. So there's some pretty interesting things it found already. I found something left over. But notice here, I found some stuff like this. Like it's like, hey, I found like JSON being used in here. That's pretty interesting. I found that this table was used specifically as a hub for the database. Like it's finding information about the schema almost in a way that's contextual to my system that I might have a hard time just manually figuring out. One of the things that I want to show you that's pretty cool, and I've got this in my demo notes here, is this. I can say something like this. What is a chart repository? Because I was like, because I built this in the system. Let me see what it says here. A chart repository, as it turns out, is a set of tables and objects to go build a chart, this digital chart system. In fact, it's an actual program. Chart repository is a C# program. That's the thing that's powering that entire unit board with all those digital charts. So this is interesting. I ask it a question about a semantic of a word that's not in my database. It's part of my code. It was able to go look at that code and look at all its usage and my schema and tell me exactly how that app that I built is using those tables. Okay, that's good stuff. If you're a developer, and especially if you inherited an application database, and you just start figuring out what this thing does, go use this because it's intelligent to work with our extension to explore your code and your schema together to discover what this database actually does. In fact, I haven't showed this here. It can build a separate diagram for you, however you want it to be built, to show you dependencies, those kind of type things. So check that out. That's not specific to Hyperscale. That can work for SQL Server, Azure SQL, anything you want it to be, but it's really nice in this case to show that. Okay, that's the fundamentals of this database. Any questions so far? Or it's like late in the day, man. Like it's getting late. I don't know if I can consume all of this. Yeah.
So we've been using Hyperscale since it was in preview.
Yeah. Well, that's a long time.
Yeah, it's been great.
Yeah.
Some of the redundancy, we found that out, like kind of got locked in here, but we use the one replica and stuff here.
One HA replica. Good.
And one of the things that we had trouble with is that in the Azure portal, you get like recommendations for indexes and all that kind of stuff, and be able to see like the graph if you roll into the logs, but that only seems to be on the read-write copy, and we had no visibility into the read-only copy.
The HA replica of what you're running the reads for.
Exactly. So sometimes we have performance issues, and we have no visibility
to the read copies itself. So a couple of, so I don't know if you heard all that, but the question is, I have performance insights into the primary compute, but when I do read copies on the HA replica, I don't have those insights, right? I'd have to go double check to see if there's some DMVs that would help you specifically to those replicas. There's two things in my mind. Number one, if you did use name replicas, there are insights there because that's a separate server to look at. Number two, you've heard of Query Store, that concept before. We in SQL Server have Query Store on secondary replicas. And I'm gonna need to double check, but it may work actually in these HA replicas. That might be an option for you. So if you'll ping me separately offline, I'll go research that for you and see. Because that's a good question. We should provide that for you. Just bobward@microsoft.com. Did I just say that on a video? Oh man, I might get a lot of emails. I don't care. No dot, no dash. When you've been on Microsoft Mail at this company before, you don't have a dot or a dash in your name. So, okay, remember we talked about like learn the fundamentals, build it. We're now talking about secure it. What's different about securing it? I already alluded to a few things in that diagram in the code. Number one, please, if you're going to refactor your app, go passwordless. Let's say it again. Go passwordless. And how do you do such a thing? Well, Entra is your way to do that. Entra supports this concept called a managed identity. And in fact, I'm going to show you in the code, it actually supports this concept called Azure Active Directory. That's the former name of this, default, which is really cool because it can use a managed identity or something called an access token if you're logged in locally. So there's a way to go passwordless, and you need to really take a look hard at that. What about networking? In this particular case, I'm using just what's called a firewall rule on a public endpoint for my hyperscale. However, we support this idea of something called private link or private endpoint, to where your virtual network would be connecting into ours, and there's nothing exposed to the internet at all about your IP at all. That is the secure way to go to secure the networking of your hyperscale. Remember, you don't control the virtual machines of these things, right? So we control all that. So there's got to be a way to secure your network, and private link is a way to do that. Authorization, data, and use. I talk about this concept of row-level security and this concept of session context. That's the way for you to go in and set a context for a user if your app is using this global managed identity. And let me pause for a second and tell you why this is important. Because if you use a managed identity, it's perfect for connection pooling, right? Because we're all using the same connection authentication. So pooling works beautifully. If you log in per user with authentication, you've blown pooling, right? Because everybody's got their own connection and their pooling is useless. This is why this row-level security session context can really help you to set the right context and session for the user, but still use a single login. And we support transmit data encryption by default in these databases. What's nice is that you can use a customer managed key, your own key, and now we support a concept called versionless keys. So you go in and create a customer managed key in Key Vault in Azure, and you do what with these keys? Typically, you rotate them. You have a policy to rotate and change the keys. Well, if you tell us this key you're using, we can go look at the latest key for you automatically, and there's no rotation in SQL Server now. That's awesome. So being able to just say, hey, here's my customer managed key, you figure out when this rotates and handle it, that's a really nice feature we've added. Microsoft Defender for SQL, which we're not going to dive into today, is a really nice way to do things like threat detection. And if you're looking at things like auditing, Azure SQL Database Hyperscale supports auditing like SQL Server does. But one of the cool things it supports, like SQL Server, is a concept called ledger. And if you go back and look at the diagram, which we can show you a little bit later, what we decided to use ledger for is this. When we are going to do agentic operations inside the database, like taught to a chat completion model, we're going to audit that in a ledger. That table is immutable. So even DBAs can't go in and delete the data. They can't even drop the table. Or if they try to drop the table and have permissions that we keep around the drop table. These ledgers are always there. So now if somebody says, hey, I need to audit how AI is being used in your system, you could use an immutable ledger table to audit all AI operations in the database. And you can say, yeah, here's my audit right here. You decide what that table looks like. It can be date, time, user using the AI tool, what session context was going on, what model we were using, what was the response for the model. So it's a pretty cool way in the database of auditing AI. Okay, so those are the pieces that I talked about here. Role of security, session context, TDE, and the ability over here to this managed identity. So let me show you a couple pieces of that. Yeah, go ahead. Sure. Yeah. This one here or the one before that? That one? Okay. There we go. The dependency, what is the dependency of using Entra-only managed identity? Here's the dependency. You must be authenticated with Entra. So if you're running on premises, you have to use Azure Arc. So if you've got an app that's running not in Azure, you have to use Azure Arc to be allowed to use Entra because it's an Azure service for authentication. Or if you're in Azure, you would use Entra, which is built into your Azure tenant already. Like when you go into Azure and you log in to the portal, for example, you're using a Entra account to go do that.
What I will ask is our web application have already tied the our application. But can we keep that and just moving the SQL database from the other tier?
Yeah, the question is, can we still use our authentication method and use our database or Hyperscale? You absolutely can. No question you can do that. So the dependency of managed identity is not required to use managed identity for Hyperscale at all. I'm just giving you a suggestion to go passwordless. But yeah, all of your current authentication ideas of SQL auth, Windows auth is not supported, so you have to use either SQL auth or Entra authentication. However, one of the cool things you can do if you want to lock this down at some point is you can do Entra only. So you could say, look, I don't even want to allow SQL auth for my database. I don't want anybody touching SQL auth anymore. It's a bad thing because it's all password based, right? So you can go to the database and say, I'm not even going to allow SQL authentication anymore. Entra is the only way that's allowed, even for admins to get in. You can do that if you want to. Yeah.
Is about what's the mechanism we can use to
ETL.
scalable that also Azure the original tier.
The question is, like, how do I do ETL processing, change event processing, all those kind of type things? CDC still supported. You could write Azure Data Factory pipelines if you wanted to. However, there's a new thing called change event streaming that's just come out. That is supported on Hyperscale. Change event streaming is a true event streaming, not CDC based, where you consume a stream of data from our transaction log into an Azure Event Hub. That could be the way you want to consider looking at changes going forward. And that's in public preview today for Hyperscale. Change event streaming is what it's called. I would call that the next evolution of CDC, for example. Change event stream. Okay, I want to just show you a couple things. The one thing I want to show you here, if you've never written code before with Entra and you're like, how hard is this thing? I don't know how to do this. I wanted to show you this. Let's go over here in the code. Actually, let's go into our runbook and say, let's run demo 2. This is the beauty of prompting because this is going to go into that skill I said and say, hey, what are you supposed to be showing? And it's like, okay, I want to show a couple things. So in the actual app itself, if we go over here, when I say all providers, that's like everybody. That's like some master password, right? When I go click on Claudia only as chief of staff, here's what that's doing. We're still logged in with a managed identity. But what happens is that's making a new connection to the database using that identity, but setting this concept called session context. Session context is like a stored procedure. You run the stored procedure, you set the context to Claudia. On the SQL side, the row level security rules look at the current session context and apply the rules based on that. This is why the number of patients change. Notice here that the name is Claudia Ward across the board. It's not anybody else in the system. So now row level security is applied to that. In fact, when we look at the chat session later, you'll see here, this is going to change context too. To allow Claudia to chat and get assistance for things that she has authorization to do. The search patients for the students is wide open for them. There's no security specifically applied because we're letting them look at any clinical case for research purposes, and that's all anonymized anyways. So that's a little bit of look. Let me show you a little bit of the code for this behind the scenes. I want to make sure I get the right code here. So over here in that repo I showed you over here, because you got to show some code, right? I use C#. You can do whatever you want to do. We support all the providers you want. Python, you name it, we've got it, right? So I just use C# in this case. So I go look here at the source. Now I've got it broken down the source into 3 components. Remember that diagram in the beginning? This is the data access layer for all the database calls. This is the Blazor app, and this is that agent I talked about. That's a Microsoft Agent Framework client to talk to Data API Builder. So down in the data layer itself, I could look at this connection factory. Let me get that open for you so you can see it. This is as simple as it gets right here. When you do one of these stream connection builders, you're going to do this. SQL authentication method, let me move over here. Azure directory default, you see that right there? That's as simple as it gets. I'm using a connection builder. Maybe you've used connection builder methods before in C# before. It's an easy way to build connection strings. And by using this, the client will look at the current context. If there's a managed identity that's set up for the current context, it'll use that. Otherwise, it'll use the current logged in Azure account. Like in my case, I'm on my laptop. I can't put a managed identity in my laptop. I need to have like Arc connected or something. But I'm logged in with Azure. So this is really cool because it looks at my current Azure context and says, oh, just use that as the current context. Now for my demo, I'm Bob Ward. I have access to all of this stuff. For an application in Azure App Service, you would go in and apply in the portal a managed identity that you assign to the app service. You would then take that managed identity, that same one, and you would apply that to Hyperscale. So now you have this identity tokenized authentication between the app and SQL Server itself. For me, I love the default. You can put in managed identity, but I love the default because it doesn't have to use identity. It can use whatever it finds on the local context of the application itself. But that's as simple as it gets from what you may be using today to connect into the database. Now for row-level security, let me pull that up here. For row-level security right here, you can see right here, chart repository. Remember that chart repository I talked about? Chart repository is like this global set of code that's displaying those cards for the different patients. So we go look over there for chart repository. Let me get rid of this for a second. Right here, do you see these calls? Set session context. So what we've done in the app is we found out, we were to inquire who was the user that was currently logged into the app. We could inquire that in the app. And then we use this stored procedure. We're just sending a procedure to the engine itself to set the context. And it fully supports connection pooling. I'm not destroy connection pooling with this. When you do a connection pooling, these reset connections that happen every time you reconnect, we'll get rid of that context and use another one. So I've been able to use these procedures in my code to take the current login user, which in this particular case is an admin, could be Claudia, and set the context. So on the backside in row-level security, I have a call to say, what is the session context? It's like a T-SQL function. So I take that T-SQL function, I make that part of my criteria of row-level security. So I don't hard code in who has access to the rows, I just use the context to make that decision. So it's only going to show, in this case, the context for the doctor because inside my tables is, guess what? The doctor assigned to the patient. So I can just compare them and only show the ones that they're assigned to. Now, what you might do in a hospital setting, I talked to my future daughter-in-law, you might create like a group of doctors, like a care team that has assignment to a patient. And then you could use row-level security to do that same thing. Is this person part of the care team that's assigned to the patient? Because what we don't want to do is have some rogue person in the hospital getting access to patient records. So I thought I'd show this in a hospital setting because I talk to people in the healthcare industry that care so deeply about privacy of data, especially when it comes to AI technologies. So that's another example of how row-level security can actually work. Yeah, let me bring up this. You had a question about this, or can I bring the deck back up? Absolutely. In fact, let's go look at it real quick. It's like a function that you write. So it's right here in security.sql. So if you go over here and you have access again to all these scripts. The cool thing about row-level security, it's been around for a while. Let's see, let's find that one. Yeah, right here. And then if you look up here, it's a function. Let's go here. So you provide a function like this and you're going to bind to this table. And look at this function. You can do also, note it's using the session context function. You can do anything you want here. Be careful though. If you make this too complicated, we apply that as we're looking at each row as we run a query, right? So if this thing, almost like using like a login trigger function or something like that, if it gets too complicated, the server has to apply this every time you're running a query against a row. So if this gets too slow, you gotta slow down your query performance. But yeah, here's how I use that session context to make a decision. Should this person have access? And it's a function. So the function is applied to your query and it can return no rows or a certain number of rows based on this criteria. Dynamically giving you, again, row level security based on your data. That works against any version of SQL Server. So cool way of showing a security model. Okay. So let's talk about scaling it. Just do a quick time check here. I have what, 20 minutes? 23, 24 minutes, or you'll fall asleep? Is that right? 24 minutes? Okay. So, okay, let's talk about scaling because we also want to definitely get to modernization. So we talked about the scaling of cores themselves. You can change those cores with a little slider. I don't recommend you use the slider. Do it programmatically. Like put that into your processes somehow with a script. All the different command line interfaces support changing cores. Here's the cool thing about changing cores. Very minimal downtime. Because what happens is when you change cores, we might be able to change that restriction on the current compute you're on. Like we may do it there. But if it gets too large, we may have to actually build another compute. Because maybe the current VM we're running you in can't support 192 cores. Here's the cool thing though, that change happens at the very end. So when we're making this change, we'll spin up another compute if we have to, and only redirect you automatically over there at the very last second. So it can be a retry for your app to do this, but it could be minimal downtime. I have a customer, before we did serverless, that would dynamically change cores based on the use of their app. They wrote a piece of code that would go in, depending on their app use, and change these vCores, like only typically at night when the system was lower, and then their app would have built-in retry. So they were effectively changing their compute costs per the needs of their app. Now we have serverless, which actually will do that automatically in the back end of the engine, but you can't actually do that. Remember, read scale up to 30 name replicas, separate configurable compute. By the way, each replica can be its own compute. You may set up different named replicas for different read scale reasons and have different compute for each, depending on what you're doing in your app itself. Auto-growing storage, pay separate for compute. This is such a big point I want to point out. You do not pay for max storage in Hyperscale. You just pay for the storage you're consuming. It's independent of paying for compute itself. We do have the concept of elastic pools, as we do in general purpose service tier. You can pool a set of databases together for Hyperscale. You pay for the entire pool compute. Now everybody shares from that compute cost. If you have a set of databases that are related from your application, it could be a way to save money for you by using elastic pools. And then, if you want to simulate the surge, here's this thing coming soon called SQL Sim. So maybe we'll go take a look at that real quick here and see. I think I've got a little demonstration for you. So let's go back over here. Let's see, I want to run demo for SQL Sim to simulate scale. Now, why did I build this thing? I built this thing because I was trying to simulate how hyperscale fast it can run. But how do I do that? How do you go build an app that hits 192 cores? So I didn't, instead of building like an actual program and then how do I simulate a bunch of users from the website, I built a SQL simulation. This is a program that's written in C# using ODBC, C++ using ODBC. I chose the C++ is where I started my whole life as a programmer, actually C, but so I wrote the lowest level that I could actually think of. And this thing here, as I set up, it's going to go run this SQL Sim utility to simulate a set of users surging to run against the database. SQL Sim has this report option that I built in. So when this thing runs, when it gets done, it'll build an HTML report we can bring up and see the performance statistics of the actual queries. Because in the tool, I built in query stats. So when you run the tool and use the right option, it can come back with all the stats of how long each query took, CPU utilization, IO utilization, everything behind the scenes. Or you could not use that and just use the query store to do the same analysis. Behind the scenes, though, I'm going to flip over while this is running and show you in the repo. Let's do this. Let's just have some fun. Why not show you something that you haven't seen yet before? So here is what this is going to look like. This is a private repo right now. Let's open it in GitHub. This is what it's going to look like. SQL simulation tools. What it's going to ship with to begin with are these two tools, SQL Sim and SQL PySim. So SQL Sim is ODBC based. You can give it a JSON file and give it a set of SQL scripts to run per user. And then I built a Python version of it. Just today, I'm building a native Linux version and a Mac OS Silicon version as well. So my intention is that you can go take this command line easy, and it's by the X copyable type thing. Like you just stick the executable on your machine and just go and run it. And then you give it all the options you want. You give it a script, an ad hoc query, or a JSON file. And then what's even cooler, what I'm also going to ship before I ship, is you can do a replay. You can take an X event trace from your system and say, here's all the queries I run, turn around and replay that for me and show me the performance. You can do A/B simulations with it as well. So this is going to come out end of August. I'll make it open source so you guys as community can like do PRs and fork on it. Then the intention is I've got some ideas to go further. Anybody use HammerDB before? So these are tools that I want to build so that you can do TPC benchmarking type tools, where instead of using SQL Sim, which is ad hoc based, these are built to actually use the actual benchmark itself. It's not an official benchmark, but it's benchmark-like. So these are tools I'm trying to provide you to do scaling to test out the power of hyperscale. And I built, like demos you're going to see in the keynote tomorrow, were built using this technology. Okay, I think it finished. Let's see what it says. Let's see. Oh, okay, did it run? Report auto open, did it? Oh, it did run, yeah. So this is what a report looks like. So you then could go, and so my intention, by the way, with the replay is if you replay it on 2 servers, I'll show you a comparison of a report like this. So you can say, hey, what does this report look like compared to my 2 runs? But yeah, CPU time, by query, IO, the whole thing. A free way to go out there and do performance scale testing against, and this works against SQL Server, Hyperscale, doesn't matter what it looks like. So it's coming end of August, free open source tool, Python based, C# based, C++ based, Linux, Windows, you name it. And then there's an intern at Microsoft that pinged me while he was here this summer and said, can I go do a PR on your private repo to be published because I did a project based on this thing? I'm like, sure, yeah, go for it. Right. Okay. The thing I want to show you on scale. Okay, the thing about scale is this. Let's go look at the vector searching. So in this, hospital dashboard, we have this research for students. And so notice here they put in the word elderly constant congestion, like I told you earlier. What's happening behind the scenes? We're using a vector search. We're going to show you vector searching in the modernization section before we're done real quick here. We're using a vector search against the database, but we're doing against the name replica. So the key here is that I don't want the students' research to interrupt hospital operations. That's my goal. But I don't want to pay for the same compute, so I don't want to use the HA replica. In fact, I want to reserve that HA replica and not read from it. Like be available anytime for failover. Because if you're reading from it, we can fail over to it, but it might not be as fast if you're pounding with read operations, right? Just like an availability group replica. So I'm going to use that name replica as serverless and let the students hit it. But notice here, students can come in and do any searching they want, but it's nothing about the patients, all anonymized for their patients, but it's general information about clinical notes. I'm really impressed with AI models. I built all of this data, all these examples, everything. And again, the idea is I want to go do research as a student to find out, hey, I'm looking at a patient that has a certain type of thing. Can you help me? But I'm doing that offline of my studies. I'm doing it live on patients. So it's more of a research project thing. But let's say you're at a teaching hospital. They may want to perform these operations, but not affect the actual primary replica. So that's a few concepts on scale. All right, any other questions about scale? By the way, one other point about scale, we don't scale for bad queries. You know what I mean by that? Like if you have very poor queries from your application, we can try to use parallelism in SQL Server to make you faster. That also might cause you problems, right? Because using parallelism. But I can scale as many vCores as you want. But if you just have really poor queries in the system, it doesn't matter how many cores you can put out a problem. Now, what you're going to find though, is you can get away with that. And I've seen it because people migrate from SQL Server to the cloud. They'll run a SQL Server. It's a big iron machine with a lot of cores, a lot of memory. They'll move to the cloud and say, I really only want like 32 CPUs, and performance goes nowhere. They're like, what happened? I said, well, look at these queries. They're horrible. Index scans, hash joins all over the place. They said, well, it ran great on my machine on SQL Server. I'm like, yeah, that's because you poured just a ton of hardware at it. So that one of the most common things I've seen from migration is customers wanting to cost optimize in the cloud, but their app doesn't support it because they just got away with it in the local on-premises. Not a criticism of any of you, it's just something I've seen over and over and over. So scaling is important, but you only scale as good as the queries you're feeding at the system. Yeah.
And then for free read only replica. All right, so this replica versus the Apple one, is this
So the question is that does business critical, which is another service tier of Azure, it does provide free read replicas. It provides HA and 4 replicas for you to read from, and that's part of the cost of business critical. However, if you take let's say a named read replica as serverless and use Hyperscale, it's going to be cheaper than creating business critical, even with those replicas are built in, because business critical is more expensive. Business critical is a great service tier, don't get me wrong. The only reason today I would consider using it over Hyperscale is I need latency for my log operations to be like sub-millisecond, like really, really fast, because it has local SSD drives powering log operations. For Hyperscale, we're not that fast, but because of that separate log service, we're super fast. So it's faster performance than general purpose. We can blow it out of the water. It's not going to be as fast for the latency of log for just business critical. But the only people in the world that I see need that are like NASDAQ, like the London Stock Exchange or something like that. Most OTP apps don't need that type of log latency that I've seen from my customers. So the question is that is the functionality from Replica Summer, it's the same SQL engine. So yeah, there's no difference in the name replicas capabilities than you have on your primary, except you just can't write to it. It's a read-only copy of the system. Okay, let's talk about HA. So it's very, very important to know this. These built-in replicas are hot standby replicas. It's like an availability group replica in that case. So a failover is very fast. However, to remind you, you don't have to have it. You can still do failover with no replicas. It's just slower because we have to go bring up another primary compute, attach it to a page server, and get it ready to run. So a failover is slower without a replica, but you can save money by doing that. The more replicas you add, okay, the better resiliency is for these failovers. Let's say you have one HA replica and it's not available. We need to failover. We got to spin up another primary compute for you, right? So if you have a couple HA replicas, the chances are both of them being down are less. So more resilient, but the SLA doesn't change. The highest SLA for Hyperscale is zone redundancy plus these an HA replica. Again, point in time restore, automated backups. There's a slide bug with a comma there. I'll fix that. There is no native backup restore capabilities in Azure SQL database, including Hyperscale. So today, you cannot back up the database yourself. If you want to copy the data in or out, it's a copy operation. However, with our automated backups, we're doing point-in-time restores in super fast time, as we just talked about. The other thing I didn't mention here is the ability to do geo-replications. We have the ability for you to take a Hyperscale database and replicate it to another region if you want to for further DR purposes. And in fact, you can do what's called a failover group, so you can auto-fail that over or manually fail it over. So if you want to be able to do what we've built for replicas in a given region, you can do it across another region if you want to, and you can read from that region as well. But that's another way for you to extend the disaster recovery of Azure past this zone redundancy. I have a lot of customers that zone redundancy alone has been fine for them. But what if we had a region outage? Because these zones are part of your region. If the entire region was down, then what are you going to do at that point? Now, if you've got geo-zoned backups, you can actually restore that into another region. Or if you have a replication failover group, you can just fail over to that other region. Okay. Let's go. Oh, I'm going to show you something really quick on scale that I thought you might find interesting. I only have 10 minutes. It's okay that I only have 10 minutes. You know why? Because I'm not going to show too much that I'm showing the keynote tomorrow. Because Anna told me, she's like, now if you show everything in your hyperscale session on AI, what are we going to show tomorrow? So anyways, I know you're laughing at that. You have to come. There's another reason you got to come real quick to the keynote if I don't get to this slide. Have you seen our certification called DP800? I mentioned it in my session yesterday. We have a new certification on DP800 for SQL AI. Would you like a free voucher? Come to the keynote. We'll give you the code. I know it's just, look at his laugh. It's like, come on. But seriously, in the keynote, we'll show you a code to get a free voucher to take the exam. I want to make sure I mentioned that. Okay, let me go back over the portal real quick. A couple things I'll show you that are really interesting. So it's under, management, settings, maintenance. A couple of things. Number one, we have maintenance windows. Now, we may, from some reason, of course, have to patch SQL Server. We're going to have to take it down to go do that. And you could be slightly down. And we have planned failovers to do that. Well, we have something called maintenance windows. Here's the default, any day of the week, but you can define custom ones if you want to. The thing you can do is you can get alerts. So we can provide you alerts if we have to go take a planned outage happening. And this is the other cool thing. What if you'd like to go test a failover? We have a restart button now. So if you'd like to go test a failover for Hyperscale, you can click this and you can test to see how does my failover working, like a kind of a DR type drill if you want to go do that. So that's a new feature that's in public for you to try. There's also a PowerShell version of that to go run. Okay, let's talk about modernizing it. And these are the things I told you before that are in the actual diagram architecture of modernization. We have enough time to just show you what this looks like and show you in the app how we made this possible. This is really important. I want to show you what's possible with SQL now that you didn't even imagine is even remotely allowable in your system. Number one, the researchers were using a vector store in a name replica. So we built embeddings in our system through T-SQL. It's all built in the system. We're using something called an embedding model in Microsoft Foundry to do this. So Microsoft Foundry with Azure OpenAI, whatever model you'd like. So we can easily integrate with Azure OpenAI or AI models in the cloud to make that happen. That's all stored in the database. In addition, that button to get a clinical request, which I'm going to show you in a second, that button to get that is using a stored procedure inside SQL. That stored procedure is calling a REST call to another Foundry model to get clinical assistance. What are we doing? We're taking data inside the database, passing it to a model, and getting back this advice. It's like a RAG pattern, right? Well, what's the cool thing about this? The app never saw that data. All the app knows is it needs to call a stored procedure to make that possible. The app never looks at the data that's sent to the AI model. That's all happening inside the engine itself. So you've now abstracted down for developers to make sure that they're not calling these things to do that kind of type functionality. However, we wanted that chat functionality in the database. So in order to do that, instead of using it inside SQL, what we did is we actually built an MCP server using Data API Builder, okay, that's running in a separate like container. We're using the Foundry GPT model to make this happen, and we built an agent inside our app to support this chat. That agent, the way it works is it talks to our MCP server for everything. The agent never runs any SQL code to make that chat happen. All the agent knows is it needs to call stored procedures in here to make all that possible. So that chat assistance all happening in this context, but the AI model is just looking at what the MCP server exposes, which are stored procedures, to decide what to do. The procedures in SQL make all that happen. In addition, the last thing I want to point about regex is we're looking at the notes to bring out actual vitals of the actual string itself. Let me show you that real quick. 7 minutes. You're about to fall asleep. I get it. Okay. So this is that app. This was that research I showed you. This over here, well, let's make it an Azure call. Oh, here we go. So let me go to Claudia real quick here and look at Art Vandelay. No laughter? No Seinfeld fans? Oh, you got it. Okay, fine. This occasionally I get a Seinfeld fan. So when we click clinical assistance, look right here what came back. This is us calling that stored procedure in SQL Server, taking data for the patient itself, vitals, clinical notes, passing that to a model saying, hey, can you give me any assistance for what we should do with this patient? And look what it did. It came back and actually gave information about the patient and what might need to happen. And by the way, it gave some sort of like a high status. We told it, by the way, based on certain criteria, you give us like low, medium, high. High might be like, we should really pay attention to this based on certain criteria that we defined. And the model actually gave us that back. So that's inside the chart itself. Only Claudia can see that because she has access to that. And the other thing we did is we put over here for all the doctors this AI chat assistance. Notice we have certain prompts. This is that agent running in the app itself, calling our MCP server, and just allowing us to go do certain things like find the priority of patients. That's using an AI model to use our tools to go back and say, yeah, go look at these patients. Now, how do they know how to prioritize things? Again, I said this earlier. It's using its knowledge of medicine to say, based on all this stuff you told me, I think these are the patients you should look at first. I did show this to my my son's family. Like, this is pretty good stuff. Like, hospitals could probably go really use this kind of technology. Maybe I should. You can cut the video. Maybe I should start a new job, a career, building hospital systems. So these are the kind of things we're doing. The other thing I was going to show you down here was these clinical notes have all the notes from the doctors. You see right here this concept of these, what we extracted. We did all that with regular expressions. Some of the vitals that the doctors took were in the notes as text. We use regex to go pull out some of the key vitals in the chart. Now, you might have in a real hospital system monitors that actually show you those kind of things, but we were able to go look at the doctor's notes and pull out some of these key pieces of data, which is pretty hard to do actually with like a light clause or something. So regex inside the engine brought that back, and we exposed a view for the app to use to actually go get that information. So that's kind of a look at the monetization story. Again, a combination of JSON, regex, AI functions in the engine, vector searching, and AI agents outside the engine using our MCP server. Okay, and that's that architecture diagram again. You have full access to go look at this yourself and kind of take a nap on a Sunday and figure out like, man, is that really something I'd ever go build? The hyperscale can support it. And one of the things I think it's important to know here, that's a lot of work happening against the database. But because we think we can scale from 2 to 192, from 10 gig to 128 terabytes, we think we have what it takes to make a system really, really big, a system wants to grow to its largest capacity. Okay, so this is that certification I mentioned earlier. Tomorrow in the keynote, we'll give you a code where you can go in and use a voucher to take this for free. I will tell you that this is really, really exciting. You know why? Because things I showed you in that diagram are all in the certification. So if you want to go show, hey, I know SQL AI technology like vectors and using chat completion models and agents with MCP servers, that's all covered in this cert. A lot of great success in the SQL community for people taking this cert. And it's not just for hardcore devs. This is for anybody that knows SQL. If you know SQL, you don't have to know AI. Take some of the prep materials, go through and look at it, go look at some materials I provided you, and you'd be surprised that you'd be able to go past this exam. Go on LinkedIn, people post a lot about their experiences taking the exam and prep materials they've actually used. So I've got some resources for you to learn more. Up at the top are the ones that I talked about, where the deck is, where the GitHub repo is with all the code, and this new Azure SQL Foundations, which is a video series that Ann and I filmed. It'll be coming out here in a couple of weeks, I think. And that's got fun music on it and all that kind of stuff. Anyway, it's a pretty good video series of us talking about hyperscale from end to end. Especially, we'll go to the details on how to do a migration that I didn't show you today. I know we're at the end of our time together. Is there any questions, last minute questions? Yeah.
What does the decision tree look like when it comes to Fabric against Hyperscale?
You mean like SQL Fabric? So the question is that how does SQL Fabric today, SQL Database and Fabric compare? That's using what's called the general purpose service tier. So that's not going to be able to go power the scale of what I talked about. I mean, it's going to be like right now, most SQL Database Fabric customers are using it for like smaller or mid-tier type database applications like metadata stores and operational stores. Nobody's trying to use that as an OTP app today that I've seen. I think we would love to at some point make it that, so that hyperscale could be running in Fabric, for example, in that environment, but it's not ready for that level yet today. In fact, it's using serverless also behind the scenes. But by the way, it's the same SQL engine. So some of the stuff we talked about and showed you here from like regex, JSON, AI, those are actually all available in SQL Database and Fabric. Does that answer your question? Come talk afterwards if you have some more. Yeah.
How did you make the decision in your design that this part AI goes through the store procedure to perform the other one?
Yeah. The question is, how did I decide to use the store procedure in the engine versus the agent over there? Some of it was my own decision. Some of it was I wanted to show you different ways. Like you didn't have to do it all that same way. You could have put everything in that agent if you wanted to, right? You could have put everything in the store procedures in the agent if you wanted to. So I want to show you different possibilities of different ways to use AI technology. Any other questions? Hey, thanks for sticking around this afternoon so late. I know it's late for you. Enjoy the rest of your time. We'll see you tomorrow. Thank you.